My name is Patrick Raney. I am WR MEADOWS Architectural Specialist for Northern California, Northern Nevada, and the Pacific Northwest. For those of you who aren't as familiar, let me share a little information about our company before we get started. The WR MEADOWS company started in 1926 in Elgin, Illinois. Next year we will be 100 years old, which is something we're very excited about. And we're headquartered now in Hampshire, Illinois. We currently have 13 manufacturing facilities and 4 warehouses strategically located around North America, and that includes Blue Ridge Fiberboard, which is a part of the WR MEADOWS family, and also our DecoSeal division, which supplies a number of products specifically for the pool industry. And lastly, I just wanted to mention a couple of exciting developments that have taken place in recent years. First, we started 2022 by acquiring the Gemite company based in Canada, which produces positive and negative side waterproofing products, as well as a number of specialty liquid products. And secondly, we recently opened our new Learning and Innovation Center at our corporate facility in Hampshire, Illinois, which will now give us a much greater ability to develop new products and technologies, as well as testing capabilities. So those are some recent developments that we're really very excited about. So here's a map of our various locations that we have in place to serve you in the US and Canada. But I also want to mention that our products are available worldwide. So wherever you may have a project, we can certainly be of help. So we started with one product back in 1926, which was asphalt expansion joint. We now offer over 300 products to help protect your designed structures. And from our Division 3 offerings that include expansion joint materials to structural and surface concrete repair materials, epoxies and grouts, to our liquids line that includes curing compounds, curing and sealing compounds, and sealers for decorative concrete, to joint sealants. And then our Division 7 products, starting with underslab vapor barriers and retarders, to air, water, and vapor barriers for above-grade applications, to our below-grade waterproofing systems. And with the soundproofing and insulation board products of Blue Ridge, we really have a full line of products to help in protecting the building envelope. So again, these are some of our subsidiaries, again, all part of the WR MEADOWS family, with each of their logos represented here. So with that out of the way, let's get into today's presentation topic, which is polishing concrete floors. So we just want to see an overview of polished concrete today. These are some of our objectives. And understand that the process not only incorporates the grinding and polishing procedure, but also the equipment involved in the fact that there is a concrete densifier used during the process. As far as the benefits of polished concrete, we'll be discussing this more in depth later on in the presentation as to why polished concrete is a very advantageous system. So polished concrete is a practical, decorative, and economical floor system for really any facility, and has become one of the fastest growing systems to ever hit the flooring industry. But we need to understand that this is a multi-step mechanical grinding and polishing process that utilizes tooling that consists of industrial diamonds. And also critical to the success of this process is the application of a concrete densifier to help level, densify, polish, and finally seal the floor from within the interior of the floor surface. And again, we'll elaborate on all these points as we move along. So where can it be used? Well, the answer is just about anywhere, right? So as we can see from the slide, and we've all seen polished concrete floors in many of these environments, I'm sure, even if we didn't realize it. And we'll look at several of these applications as we move forward. So this looks like a manufacturing or maybe a warehouse facility, and notice the appearance on either side of that middle traffic area. So in this case, that middle area has been polished and the areas on either side have not yet been done. So what will likely be happening here is that those two areas will get done when the facility is closed, or they can temporarily shut those areas off and take them offline. This is a good example of the fact that to do the polishing process, you don't necessarily have to shut down an entire facility. It can be done one area at a time so that the facility can remain open and operational. Another good example, here's a cafeteria. And note the fact that there is some color incorporated in this floor. There are various coloring techniques when it comes to polished concrete that we will discuss further in the presentation. But one other thing to notice here is the light reflectivity. We can see the lights from above reflecting from our floor. So this is another benefit of polishing we'll be discussing and bringing up as we move along. Here's a shot of an auto dealership showroom floor. Now, this has become very popular in recent years since it combines high aesthetic value with a very practical and low maintenance floor. As we mentioned earlier, one of the many applications is residential, and here we have a residential garage floor. And again, the benefits are really very much the same as we saw in the last few slides. And in this case, the polished floor will stand up well to the heavy truck and boat and to any tire marks as well. This looks like a restaurant entryway. And again, note the coloring of the floor. This is a nice example of what a flooring contractor can do with using different colors and shapes. So here we have a race car facility. As it turns out, this is located in Southern Carolina and turned out to be a 34,000 square foot project for us. And again, notice the amount of light reflectance that's going on here. So now that we've discussed what polished concrete is, where did it originate? Well, the process was discovered in Tunisia by a contractor that worked with granite and marble. And typically this process uses a wet grinding system, and the contractor in this case tried the same process on concrete and found that he was able to get a great polish on the concrete. Well, this was noticed by one of the royals in Tunisia and asked the contractor to do some polished concrete in the palace. And being short-staffed, this contractor hired some laborers to do the work, and there was one major mistake made. They had polished the concrete dry. Well, the appearance of the floor, as it turns out, was fantastic, and this was relayed by the contractor to the company he had purchased the equipment from, HTC out of Sweden. And it was from this that the process of dry polished concrete was originated. And the process was introduced to North America by Vic International in the early 1990s. And I was fortunate enough to go along with several of my colleagues from our company to do hands-on training a number of years ago at their facility in Tennessee. And the photos coming up shortly will show you some of the same equipment that I was fortunate enough to be able to train on. So here are some examples of one type of equipment on the market. The first being the main piece of equipment, which is the grinding machine, which is on the left here. This is the machine that I was able to train on. And these machines usually have 3 or 4 heads with typically 3 to 8 diamond segments on these heads. And the machine rotates at approximately 350 to 1400 RPM and is variable based on the type of concrete and the diamond grit being used during the pass. The other 2 units we see here are the pre-separator and the vacuum. And these 2 pieces are attached to the grinding machine and are used to remove the majority of the waste and dust from grinding the floor. So it enables the control of the airborne dust as well as contaminants. This is the reason we can work on a floor without having to completely close down a facility, which we saw in one of the earlier slides. And using the dry process allows the dry waste material or the powder, the concrete powder, to either be safely disposed of or recycled. So this is a much cleaner process than wet grinding, which does still exist, but again, for obvious reasons, it's usually not the preferred method. So we mentioned earlier that this is a multi-step mechanical grinding and polishing process, and a true grinding and polishing system can range from a 5 to 10 step process depending on the floor's design and also the original condition of the floor. So here are photos of the tooling that is used with the equipment to obtain the level of grind and polish that is desired with the floor. So first we have the diamond grinding segments or metal bonds that are used for the grinding. Now these are industrial grade diamonds and are suspended in metal. They range from 16 to 150 grit segments and are used in the grinding phases of the process. This process is used to remove high spots in the concrete, as well as imperfections and contaminants, such as any cures or sealers that might be present, and also mastics or other types of chemicals. The diamond polishing pads or resin bonds that we see here are used for the polishing. These diamonds are suspended in resin to provide a higher grit and range from 100 to 3000 grit and are used for the actual polishing of the concrete. So the idea of the process incorporates different grit levels of these pads, going from a lower grit, which is more aggressive, to a higher grit. And each of these pads will scratch the floor and leave these scratches. But moving to a higher grit pad with each subsequent pass removes that scratch pattern from the previous pad. So really the best explanation of this process is to compare it to sanding a piece of wood. To finish or flatten the wood, a rougher sandpaper, i.e. a low grit, is used to sand the wood first, and a smoother sandpaper, meaning a higher grit, is then used to actually finish the wood, which at the same time also removes the scratches from the wood of the previous grinding processes. So this is the concept of how the process works. So before we even start the process, a few factors should be addressed to ensure that we get the best finish of the floor that we possibly can. It's always recommended that a mock-up be done because this process is extremely difficult to predict the actual finish of the floor. As you know, all concrete pours are different and all finishing techniques are different. So these factors will affect the final appearance of the floor, and really no two floors will be exactly the same. So we always want to be sure that the floor is clean and dry with no contaminants present and that the slab is at least 28 days old. The concrete needs to have a minimum compressive strength of 3,500 psi. A softer concrete can diminish the working life of the diamond tooling, which of course means we would need more diamond segments to complete the job, which adds to the cost. And we could potentially have some damage to the floor as well. And as we mentioned earlier, the polishing process that we use today is a dry process. And it's important to understand that with a dry process, there is substantially less waste. And as you will see, there are many passes over the same piece of floor. And with a wet process, each pass will result in a slurry on top of the concrete that would need to be cleaned prior to the next step, which is why we don't use the wet grinding process today. Also, I wanted to mention, we do have a list of certified applicators that are familiar with our system that we can provide. However, that doesn't mean that there aren't a lot of very good qualified and experienced polishing contractors out there. So really, as with all things, do your due diligence when you're checking out polishing contractors, really as you would with any other contractor. So as we mentioned earlier, the grinding process incorporates the metal bonded segments with different grit ranges. And this is done really to prep the floor prior to the polishing phase. And this grinding phase really accounts for about 60 to 65% of the total labor time of the process. This grinding process is essential to a successful polished floor system. If it's not done properly, it will be apparent in the finished product. And in the following slides, we'll see an example of the typical steps used on an exposed concrete floor that has no contaminants on it. The first step shown here in the photo that we're seeing involves a grind using the 80 grit metal bond. If the exposure of aggregate is not apparent at the initial depth set by the grinding machine, another pass can be done using the same metal bond, or alternatively, a lower grit metal bond could be used. So this is typically the second step, moving to 150 grit segment. And notice in this photo, we can see that the pre-separator and the vacuum are attached to the grinding machine, as we talked about a little earlier. And I've actually trained on this particular grinding machine and gone through all the steps that we're talking about here today. And I have to say it was a great experience to be able to do this hands-on and see firsthand why it takes so many steps to really get this right. And I was surprised how much you can actually feel the high spots in the slab as you're pushing the grinding machine over it, and how much the floor flattens out with each pass. And this is something we'll circle back to and address a little later as well. So at this point, we've finished our grinding part of the process, and the next step involves the densification process. So why do we need to use a densifier? It's possible to polish concrete without the use of a densifier. However, proper application of a densifier increases the longevity of the floor. And of course, we want our floor to last as long as possible, right? So including this one additional step of applying a densifier at this point just makes sense. A properly densified floor will increase the abrasion resistance of the floor and make the floor more scratch resistant. And the scratch resistance will help to maintain the shine. Now, there are different schools of thought as to when the densifier should be applied, but really the best penetration of the densifier happens when it's applied between the grinding and polishing phases of the process. And this is the point at which the slab is the most open or porous, if you will. So it's at this point that we can get the deepest penetration of our densifier into the slab. So how does the densifier work? Well, typically the densifiers are sodium silicate or lithium silicate in nature. And when a silicate is applied to concrete, it reacts immediately with both hydrated lime and free lime to form dicalcium and tricalcium silicate compounds. And these compounds then react with water to form CSH, or calcium silicate hydrate, also known as CSH gel. And chemical hardening and densification of the concrete occurs due to an increase of this CSH gel, which fills the pores or voids in the concrete. And the CSH gel produced in the pores is also insoluble in water, making the concrete highly resistant to water, acids, and numerous other chemicals. And if you happen to forget all the chemistry, the simplest explanation I've ever heard is this: the densifier turns the bad stuff in the concrete into good stuff. And really, that's the bottom line. So this densification of the slab is intended to be a one-time application. And being a chemical reaction, this process takes some time. So it's important to understand that the abrasion and stain resistance we've talked about are not immediate. And as we discussed earlier, the abrasion resistance protects the integrity of the floor and allows longevity of light reflectivity and shine. And we also want to make sure our floor is dry for at least 24 hours before we move on to this last stage of the process after our densification. And we'll be talking about this next, and that is the polishing phase. So as we see here, we've let our floor dry for at least 24 hours, and we're ready to start the first step of the polishing process with our 100 grit resin bond. And notice that we are still using the same grinding machine that we started with in step one. So here we see our next polishing step at 200 grit, but notice something is starting to happen here. We can just start to see the scratch patterns in the surface that we had talked about earlier, and just a little bit of light reflectivity as well. Now, when I trained on this process, I have to admit, I was starting to wonder how long it was going to take to actually see something change in the appearance. And it was really at this point that I kind of had my aha moment. And it took a while to get there. But at this point, you can at least start to see what we've been talking about. So now we get to step 6, which is our 400 grit resin bond pad. And this is the point at which we can talk about incorporating colors with the concrete. Now, there's obviously the option of adding integral color to the concrete at the batch plant, which will give us a uniform color throughout the slab. Another option is shake-on colors, but these can be somewhat difficult to use as the color can be affected during the grinding phase. And since the aggregate used in these products can be high strength, it can provide harder and softer spots on the concrete that can cause divots in the floor and removal of the color. We often get asked about acid stains, but these products basically tend to compete with the densifier for the free lime in the concrete. So honestly, these are really not the best choice. However, the use of concrete dyes seems to work very well in a polished floor system and are typically applied following this polishing phase. And there are quite a range of colors and intensities of these products available on the market now. And the applicator needs to make sure that the color is thoroughly washed and it's completely dry prior to continuing the next polishing step. So at this point, we can start to see an actual polish or shine on the floor. And this is considered to be the first, quote, finish option with most polishing systems, and is typically referred to as a satin or low gloss finish. And it's at this stage we can still see some of the swirl marks, but still a good appearance. So here's another finish step, which would be considered a semi-gloss finish. But notice at this point, we really can't see any of those swirl marks anymore. And now we can even see the grinding machine level label reflecting off of the floor. So here we are finally at the final step in the polishing process. We're at a 300 grit, which is considered a high gloss finish. And folks, this is as good as it gets. We really can't do much better than this. And this is that same race car facility in South Carolina that we talked about earlier. It's a NASCAR facility, and this finish came out just remarkable. So yes, we really can't do much better than this. This is really as good as it gets. So now we're going to talk about the products that are available to address initial sealing of the slab after the polishing process. And this slide shows us some of the types of products that are available on the market, but why do we need to do this? Well, the main reason these products are used is the fact that this densification process takes time, which goes back to what we talked about a little earlier when we said that applying the densifier causes a chemical reaction in the slab and that this process does take some time. But many owners want immediate stain resistance of the slab. And without putting a sealer or protective coating on the slab, we won't have that stain resistance we're looking for until that chemical reaction has completed. So having a sealer applied directly after the final polishing step will allow the owner to have this immediate stain resistance once the polishing process is complete. And this will also help to protect the slab as other trades come onto this floor to do their work. So just to recap, the finishes we've already seen, we have 800 grit, which is our satin finish. Then we have 1500 grit, which is our semi-gloss finish. And finally, we get to a 3000 grit, which is our high gloss finish. And notice that with each subsequent step, the light reflectivity that we're expecting increases as well. So I love this photo because now we can see a side-by-side comparison of the three types of finishes: satin, semi-gloss, and high gloss. And another way you could look at this is in terms of good, better, best. And keep in mind that you are able to specify which finish that you want on your project. This is a specifiable system. And not all projects will require a high gloss finish. And of course, with each additional step, the cost increases. So the good news is that you can choose the option that is best suited for the project. So now that we've talked about the equipment, we've talked about the process and the types of finishes, I want to talk a little bit about the benefits of polished concrete. The first is the elimination of dusting of the concrete. The use of the densifier and the reaction of the silicate with the free lime helps with this. Once the pores are filled or blocked with CHS gel, migration of moisture up through the slab is also decreased. And this decrease in moisture migration greatly decreases the amount of efflorescence that can form on the surface of the slab. Otherwise, specialty floor system failures involving epoxies, urethanes, or VCT floor adhesives can occur as a result of free lime being driven to the surface due to ground source vapor drive. Our densified concrete floor provides a water and stain resistant surface. And although the main purpose of the densifier really is abrasion resistance, the sealing and chemical resistance aspects are very good byproducts. So as we've already learned, the chemical reaction takes time to develop. One optional further step to provide immediate protection is the application of a topical or penetrating agent, which we've already talked about a little bit as well. And again, this is sometimes beneficial as the expectation of an owner is the immediate protection of the floor to staining along with that polished appearance. I think that the ability to utilize this polishing process, not only on new floors, but older floors as well, is a great benefit. It's really amazing how an old, beat up, worn out concrete floor can really be brought back to life with the polishing process. And all the benefits of polishing we've already talked about apply to restoring older floors as well. And many of the issues with older floors that we see listed here in the slide can be corrected. So here's a nice before and after shot. This is an old concrete floor with original vinyl asbestos tiles, and the grinding process was used to remove all the contaminants on the floor, and the polishing process was used to finish the floor. So this is a pretty dramatic example, I think, of what can be done to rehab an old slab and really bring it back to a usable life. So another benefit of polishing that we see is reflectivity of the floor. Reflectivity of the floor can allow lower intensities of lighting, which can allow for reduced lighting costs. But this is kind of a unique case here. In this particular instance, the contractor had polished the floor up to a high gloss finish. And although the owner loved the look, the amount of light entering the building and reflecting off of the floor actually caused it to be too bright. So they actually had to bring the shine down a little bit. That's a rare case, but it just kind of proves the fact that the polishing provides better lighting and less money spent on turning the lights on. So slip resistance. We'll talk about this just for a minute. The American National Standards Institute, or ANSI, defines dynamic coefficient of friction as a measurement that determines how much friction there is on wet level floors when walked upon. In 2025, these appear to be the two most accepted testing methods for polished concrete floors that we see on the screen here. But in recent history, the National Floor Safety Institute had developed standards that were accredited by ANSI for DCOF testing. However, that relation had stopped in 2020. So the ANSI A326.3 is dynamic coefficient of friction of hard surface flooring materials. So this covers laboratory and in-field testing. And ASTM E303, this is the standard test method for measuring surface frictional properties using the British pendulum tester. And it is used internationally and it really is a consensus standard used for testing. And for those who would like to know how a tribometer works, in the basic form, you would wet the test area, and there's a small circle or instrument with a rubber pad that is inserted underneath the machine. The test is then started by following the prompts and pushing down on the machine. And there are control parameters in place, such as feet, quote unquote, on the machine that controls the distance from the surface. And the machine then moves the pad a controlled distance and publishes the value on the screen. Now, there are a lot of conflicting articles and documents out there, and really it's up to the specifier to decide if they're going to require DCOF testing after installation or not. And the testing standard used should be researched and determined by them. So another misconception that is out there is that these floors are maintenance free. Well, that's not quite accurate. It's important to understand that while these are low maintenance floors, a maintenance program or regular cleaning of the floor does need to be done. And because these floors are so flat, best description I've heard is that a layer of dust can act like ball bearings. So keeping them clean with regular, simple maintenance is important. So here's another great benefit. A ground and polished floor is smooth, which results in less wear on tires. So if you have, let's say, a warehouse or manufacturing facility where you have forklifts running around, this aspect alone could save you quite a bit of money over time. This is a surprisingly cost-effective system, and we'll look at this further in the next couple of slides here. So here's a cost comparison of polished concrete with some of the most popular flooring systems out there, like vinyl tile sheet goods, VCT floors, carpet, and epoxy floors. And this information comes from the National Terrazzo and Mosaic Association and looks at the 20-year cost of each system and includes initial cost, replacement, and maintenance costs. And this analysis was done a number of years ago. So while all these costs have certainly increased, I think the comparative numbers still give us some good insight. So let's start with the VCT floor. The installation cost is less expensive than other alternatives at approximately $1.23 per square foot. But the maintenance cost of these types of floors per year is expensive. Regular maintenance of these floors comes out to approximately $1.47 per square foot per year, according to our chart, for cleaning, waxing, etc. And the majority of these floors are required to undergo major maintenance or replacement about every 15 years. So if we take this info from our chart and add up the cost for a 10,000 square foot VCT floor over a 20-year period, the cost over those 20 years comes out to approximately $340,000. So imagine what the cost of a 100,000 square foot building would be. Now with epoxy coating, these are considerably more expensive than VCT floors to install at about $4 per square foot. And just like with the VCT floors, there is regular maintenance. And along with that, these floors need to undergo major maintenance or replacement, usually every 6 years or so. So if we take the same square footage over 20 years, you're looking at a cost of over $240,000. By comparison, epoxy terrazzo floors are the most expensive to install, roughly around $9 per square foot. But the maintenance cost is low, just as with epoxy coatings, and the lifespan of an epoxy terrazzo floor is much longer than the traditional epoxy coatings. So the bottom line here is this equates to a 20-year cost of just over $180,000. Now with polished concrete, the installation cost falls between the previous two examples at approximately $5 to $6 per square foot range, but the maintenance cost of polished concrete is considerably less over the same time periods as the other alternatives, approximately around 50 cents per square foot per year. And as we mentioned earlier, there is some maintenance cost that does have to be accounted for. But over the same 20-year period, by comparison, it's clear that the total cost for polished concrete is less than half the cost of several of the other alternatives and lower than any of them. So this is the same information, basically just organized in a little different way. And again, a little different type of a comparative chart, really showing the pros and cons of a concrete polishing system versus several other types of flooring systems. Pretty self-explanatory, really. We won't dive too much into this one, but if any of you would like to get any of these charts we've looked at, just let us know, and we can certainly get those to you. So just to recap a few things, again, this is a one-time application that will give us a long-lasting floor. And remember, again, that maintenance, although minimal, is required. So as with everything in construction, sustainable design is at the forefront, and all products and systems in some way affect this. Polished concrete has been developed to be a part of your sustainable design and may contribute to LEED credits, as we see here, in areas such as indoor environmental quality and low emitting materials. And more details on LEED and so forth can be found on most manufacturers' websites. We have all of that type of information on our websites. Anything pertaining to LEED and sustainability can be found on our website, and we're happy to help with that. So how does polishing concrete assist with credits for LEED? So here's a bit of a laundry list of sustainable benefits that a polished concrete system offers. And all of these go right to the goal of being part of safe and sustainable construction. Does not off-gas. Densifiers typically are zero VOCs, typically made in the USA. You can read all of these different bullet points, but there's a number of sustainable attributes, all of which contribute to the bottom line. So we've covered quite a bit of information today. We've looked at the process itself and the steps involved. We've looked at the kinds of projects where this type of system can be used. We've discussed both the functional and aesthetic results of choosing a polished concrete system for your floor. And we've looked at the comparative costs of installing a polished floor versus other flooring systems. So as we said with our objectives, we hope this presentation has given you a good overview of polished concrete and given you another great option to consider when you're designing and specifying your floor systems for your various projects. So with that, thank you all so much for your attendance. We would love to be your resource for all of your building envelope needs.